So hi guys, welcome to my channel. So today I'll be solving the GFG problem today, which is sub arrays with equal number of occurrences. Again, the difficulty is marked hard and the code is also looking very big, but bear with me till the end and the approach will be like very easy. So initially, if you're solving this problem, you might get stuck somewhere like how to approach this and what's the intuition. But if you have kind of a seen this approach before, then you can apply this approach in this problem and solve it very easily. Again, I'm saying that if you're solving it for the first time, you might get stuck, but after knowing this approach, you can use the similar approach in another questions which is somewhat similar to this. Okay, so let's see how we can approach this and like how we can solve this. Okay, so given an array double r and two integers, say x and y, you have to find the number of subarrays, means the subarrays, and that to the count of that subarray in which the occurrence of x is equal to the number of occurrence of y. Means you have to find the subarrays from this array where the count of x and count of y should be equal. Okay, so let's see with the test case. Okay, so this is the test case which is given to us, and we have to find the number of subarray where the occurrence of x and y is equal. Okay, so we can see that if we consider this subarray, okay, this is 1. Now considering again the another subarray which is 2, again another subarray which is I have taken this, this and this. Now taking the couple 1, 2, okay, now 2, 1, and taking 3 elements 1, 2 and 1, 1, 2 and 1. Okay, so let's see whether the occurrence of x and y is equal. No. In this, no. In this also, no. But we can see here is the count of 1 is 1 and the count of 2 is also 1. Here 1 and 1. So we can see that yes, the occurrence of 1 and this is in this subarray, the occurrence of x and y are same, so we can consider it. Now again for this 2 and 1, so the occurrence of 2 is 1 and the occurrence of 1 is also 1, so we can consider this. Now for this subarray, the occurrence of 1 is 2, this one and this one 2, and the occurrence of 2 is 1. Okay, so it is not equal, so we cannot consider this. So we have found that there are two possible subarrays in which the occurrence of x and the occurrence of y is equal. So we can see clearly here is the output is 2. Now taking example of this 1 to 1. Okay, so the x is equals to 4 and y is equals to 6. Okay, so let's change it. Let's change x is equals to 4 and y is equals to 6. Okay, so let's remove this. Now let's see. The occurrence of 4 and 6 in this subarray is 0. We can see that the 4 is also not present and 6 is also not present, so the occurrence is 0. We can consider this subarray. Okay, the occurrence of 4 and 6 in this subarray is also 0. Okay, we can take this. Here also 0, take this. Here also 0, take this and take this. Okay, so we have found that there are in total 6 subarrays possible where the occurrence of 4 and 6 is 0. Okay, so 6 subarray possible where the occurrence is 0. Okay, so I hope the question is clear by looking into the test case, but let's see how we can approach this. So let's see the approach 1 to solve this problem. By the way, it will be the naive approach. Okay, so whatever array we are given to us, we will be calculating the sub array by looping it. Like the complexity will be big of n square by taking out each and every sub array, and we'll be checking that, and we'll be simultaneously maintaining the count of x and count of y, and simultaneously we'll be checking that at whatever positions of whatever subarray the count of x and count of y is equal, then we can say that this is the valid subarray. So we'll be considering this subarray into our answer. Okay, so but the time complexity will be big of n square. But now we have to, but we can see that the constraint is constraint is 10 to the power 6, so we have to solve this problem in big of n. So let's see the approach 2. So here is the test case, and we want to solve this problem in big of n time complexity. So how we are going to solve this? Okay, so first of all, what we are going to do is we'll be maintaining a count of x. Okay, count of x, which will be storing that till the index I, what is the count of number of x? Okay, so till this the count of 1 is 1, till this the count of 1 is again 1, till this the count of 1 is becoming 2. Okay, now similarly maintaining the same variable or same vector which is y. Okay, now it will calculate the till particular I, what is the count of y. Okay, so here it is 0. Now the count of 2 will be increased 1, the count of 2 will be same as 1. Okay, so we can see that till here the count of 2 is 1, till here again the count of 2 is still 1. Okay, so we have calculated count of x and count of y. Now what we'll be doing, we'll be calculating the difference. Okay, because every time we'll be having every time we have to check the difference, that what is the number of occurrence of x and what is the number of occurrence of y, and if their difference is equal, that means that we can consider that subarray. Okay, just see the approach and try to understand, and everything will be so clear. Okay, so 1 minus 0, it will be 1. Okay, 1 minus 1, which is equals to 0, 2 minus 1, which is equals to 1. Okay, so from here we can clearly see that we are getting the difference as 0. If we are getting difference as 0, it means that till this particular index the count of number of x and number of y is same. It means the count of x is also 1, the count of y is also 1, and the difference between those two is equals to 0. So we can increase our count variable, or we can say that size variable, by 1. It means that we got one subarray whose number of occurrences of x and y are same. Okay, next thing, till here we got 1. Okay, the occurrence of 1 is 1. If we observe the difference as 1 here, it means that 1 minus 0 has given us 1, means we are standing here. Again, after moving some distance, we can again see that it is again becoming 1. It means whatever number of occurrences present here, let's say a, whatever number of occurrences present here, let's say it becomes again a. Okay, so if coming here it gives me again a, that means I can clearly say that whatever elements present here, like x, y, z, whatever elements present here, they will cross each other and making again the difference equal to a. Okay, so I am repeating it again. Let's say the difference between x and y is equals to a. Okay, and again after moving some steps, again we are getting x minus y is equals to a. What it means? It means that whatever elements present in between, by considering this, okay, this, so whatever elements present here, the number of x, number of y, it would have cancelled each other. It means that we can take this subarray where the number of occurrences of 1 and 2 is equal. Again, I'll be making a little bit more clear by saying that we don't want the number of occurrences of x and y to be some value. Okay, if x is equals to 2 and y is also equal to 2, then we can consider it. No, we have seen some of we have seen in the above test case that if x occurrence of x is 0 and y is also 0, then also we can take that subarray. Okay, so let's see with this test case. Okay, so what I have made here is, this is our array B, A, B, A, B and A. Okay, so we'll be first initializing the count of A, means till here the count of A is 0, it becomes 1, it becomes 2, again there is no A, so it becomes 2 as it is, because till this particular index we have 2 A's. Okay, now here it becomes 3, here it becomes 3, here again we got 8, so it becomes 4. Okay, just listen it very carefully. So again, count of B, it is 1, it is still 1, still 1. Now we got B, it becomes 2, still 2, we got B, so it becomes 3 and 3. Okay, done. Now we'll be calculating the difference. Okay, so difference. Okay, so let's see, this is the very important part of this problem. Okay, so let's make a size variable, that what are the size we can take in which occurrence of count of A and count of B is 0. Okay, so now let's observe. So first thing we have to observe is wherever the difference is 0, we'll be considering the subarray. It means if we consider this subarray, it is 0. Okay, you all will be agreed. If we take this subarray, the occurrence is 0, and if we take this subarray, its size is also 0. You all can see that B and A, the occurrence is same. Okay, we can consider it. Again, B. So two number of A and two number of B, again we can consider it. Now again, BAB means 3B and 3A till here. So whatever number of zeros present in the difference, we'll be considering it in our size. Okay, so let's increase size as 3. Okay, initially we have initialized the size variable as 3, means whatever number of zeros present in our difference, it will be taking. Okay, so now moving next. Okay, so we have found 1 here. Okay, so till here whatever elements present, the difference is 1. Again, after moving some step, we found that again we got 1. Okay, if we got 1, it means that till here we got 1. It means that if we consider this subarray, okay, if we consider this subarray, then it will be saying that whatever elements present in this, it cancels each other. Okay, there is one number of occurrence of A, one number of occurrence of B, it cancels each other. So we got another subarray in which occurrence of A, X and Y is equal. So let's increase the size to 1, and by which it comes, we see the difference as 1. Okay, so it is coming from 1. Okay, let's see another interesting. If we move again forward, we get again 1. Okay, here we can see that we got again 1. Okay, so now what it is saying, if we consider this subarray, then again the two occurrence of A, two occurrence of B, they cancel each other. So again we got 1. Okay, so we can say that again we got one subarray from 1, and whose occurrence of A and B is equal. Okay, now let's see one more thing. Okay, so for this particular, if I'm standing at this one, we get 1 from this and 1 from this. Okay, done. Now if I'm standing on this particular index, now again I can move forward and I can see that, oh, again I got 1. Okay, now again you can see that this B and A is like the occurrence of B and A is equal and they are crossing each other. Okay, so again I can consider plus 1, and it is also coming from 1. Okay, so you all can see that, observe that we got 3 ones, and we have seen that if I am getting X minus Y is equals to A, and again after moving some point, X minus Y is equals to again A, it means that whatever element present in between, it have crossed each other. That's why we got the same value. So we got our answer till here is 3 plus 1 plus 1 plus 1. Okay, so now moving further, we got 0. Okay, initially we have taken the 0 value. Whatever 0 we are getting, we have calculated initially it in our answer that this subarray we can take. Okay, now it's time to consider the middle part of that values. Okay, so we, after moving some distance, we again got 0. Okay, let's see, we again got 0. So we can consider this subarray, and let's see. Okay, so the occurrence of A and B is 1 and 1, so it will cross each other. So we'll be again adding 1, and it came from 0. Okay, now again moving some distance. Okay, again we got 0. Okay, if we got again 0, then we can consider this subarray and see that AB, it will cancel each other. Then again we got size as 1, it will be coming from 0. Now we are standing at this particular index, and we have completed this and this. Now it's time to stand here and complete this. Okay, so let's remove it and stand here and complete this one. Okay, again after moving some point, we got 0. So we can see that we can consider this subarray, and like this will be crossing each other. Okay, so we can add it in our answer from 0. Now we can see that 3, 4, 5, 6, 7, 8 and 9. Okay, so let's try to see from the test case that whether it is giving the correct answer or not. Okay, so we'll be considering, in case of B we'll be taking 2, and in case of A we'll be taking 1. Okay, so 2, 1, 1, 2 1 2 1. Okay, 2 1 1 2 1 and 2 1. Okay, so what is our x? X is 1. What is our y, which is equals to 2? Okay, so let's see what is the output. Your output, it should be 3 4 5 6 7 8 and 9. Okay, let's see. Okay, it is giving 9. Okay, so I hope this clears a little bit like how we are calculating. Okay, so now our main task is to how we'll be finding. Okay, you will be saying that if we are standing at this particular index, we'll be looping and again finding that what is the further, where the further we can get the same value. No, we are not doing it like that way. We are using the handshake method to calculate the number of occurrences present. Okay, so we'll be calculating this with the help of handshake method. Okay, what handshake method is saying that if let's say the person is A, this person is B, this person is C, we have to calculate the pairs, valid pairs. Okay, so let's calculate the valid pairs between this is A, B. This is the handshaking method. A handshake with B, then A handshake with C. Okay, B handshake with A, B handshake with C. Now C handshake with A, C handshake with B. Okay, but we can see that A has handshake with B here also and A has handshake with B here also. So we have to remove the duplicates. So how will be removing? We'll remove this. Okay, now AC and CA again duplicate, so we'll be removing. Now BC and CB again removing. Okay, one part. So we got 3. Okay, and we all can clearly see that we got 3 from zeros. Okay, so we got 3. Now how will be calculating? So whatever the occurrence of 0 is 3, will be storing in the map. Occurrence of 1 will be storing in the map, and will okay, it will be 3. So now what we'll be doing? The formula for handshake is 3 into 3 minus 1 by 2. So it will give our output as 3. We can say that we got 3 number of subarrays from this 0. Okay, we can see that this one, and this one. So this is the formula we are using. After like till here we have calculated the difference. Okay, we got minus 1 0 1 0 1 0 1. So we have initialized our map and saved the count of each and every number we are getting in the difference. Okay, so 0 we are getting 3, 1 we are getting 3. Now what we are doing? We are using the handshake formula to calculate the number of valid pairs and unique pairs. So this is the handshake method which we are using. Like we'll be removing the duplicate occurrences. Means A has already done handshake with B. Now no need to do it again. So from 3 we are getting 3. Now finally I'll be doing the dry run of one more test case, and you'll be very clear. Okay, so we are going to run again a new test case, and let's see that how we are going to calculate the answer. Okay, so I have calculated the count of x. So occurrence of 2 till here is 0, it becomes 1, again it becomes 2, it becomes again 2, again 2, again 2. Okay, now till here y is 0. Okay, we got 2, again 0, again 0. We got 1 3, which is the occurrence of y. Okay, so we increase it to 1, again 1 1. Okay, so here we have find the count of x and count of y in the array. Okay, now we are calculating the difference. 0 minus 0 is 0, 1 minus 0 is 1. We have calculated the difference like that. Okay, now our task is to find the size. How we are calculating this size? This is the important part. So now our next step is to create a map in which we are going to store the variables, the occurrence of variables of difference. Okay, so 0 is present 1 times, 1 is present 4 times, and 2 is present 1 time. So our first step is to whatever number the number of 0 we are getting, we have to initialize it with the size variable. Okay, and the size variable. Okay, so the number of 0 is 1. Okay, so we initialize it as 1. Okay, because till here the occurrence of 0, we take only this subarray, and we can see that the occurrence of 2 and 3 is 0. So this is the valid subarray. Okay, now our next step is to calculate the further answers. Okay, so again we got 1. Okay, by moving some distance we can see that we again got 1. Okay, we can consider this subarray. Okay, 2 and 3, the occurrence is 1 and 1. Yes, we can consider this. Okay, so add 1, and it is coming from 1. Okay, now again moving further, again we got 1. Okay, so 2 3 and 4. Okay, the occurrence of 2 is 1, the occurrence of 3 is 1, still 1. Okay, we can add again one more. Where it has come from? It has come from 1. Okay, just remove this. Now again moving further, we got again 1. Okay, so this is 2 3 4 and 1. the occurrence of 2 is 1, the occurrence of 3 is 1, again we add it, okay, 1, where it is coming from 1. Okay, now again after coming to this position and again calculating, okay, so because it has done handshake with this, it has done handshake with this, it has done handshake with this, now it's his turn, this index turn, to do handshake with this and this. Okay, so how we'll be doing, if we move forward we get 1. Okay, so can we consider this subarray? Okay, this one. Okay, 4, the number of occurrence of 2 is 0, the number of occurrence of 3 is also 0, so yes, we can consider it. Okay, so again we'll be adding 1, where it has come from, it has come from 1. Okay, again moving forward. Okay, so can we consider this 4 and 1? Okay, the number of occurrences are still 0. Okay, then again consider 1, it has come from 1. Now we will be moving our index to this. Now if we move forward from this index, again we got 1. Okay, can we consider this subarray? Okay, yes, because the occurrence is still 0. Okay, so we have seen that. Okay, we got 1 2 3 4 5 and 6 pairs where we got the this subarray where we got the occurrence of 2 and 3 0. Now let's directly calculate with the formula. Okay, what the formula is saying, 4 into 4 minus 1 by 2. Okay, so 4 into 3 by 2, which is equals to 6, means we have directly calculated with the formula whatever we have tried on here. Okay, now with 0 occurrence is 1. Okay, let's calculate this. Okay, so 1 into 1 minus 1 by 2, which is equals to 0. Now for this also 1 into 1 minus 1 by 2, which is equals to again 0. Okay, so from here we have calculated that the subarray, the size of the subarray we are getting is equals to 7. Let's check it. 1 2 2 3 4 1. Okay, so let's see the output. It should be coming 7. Okay, so it is giving 7. Okay, so now we have calculated this, we have solved this problem by using the time complexity as big of n and the space complexity is also big of n. So now let's see what I have coded. Okay, so I have initialized the count of x array, same count of y array and the difference array. The size is of array dot size. Okay, what I'm doing, if the first element is equal to x, okay, then we'll be initializing the first element of count of x as 1, otherwise it will be 0. Okay, same doing as y. Okay, and in difference what we are doing, count of x of 0 minus count of y of 0. Okay, so first all the index is initialized. Now I'll be iterating from I is equals to 1. If I got the array of I as x, means the desired number, then what I'm doing, count of x of I is equals to 1 plus previously how many elements we got. Okay, let's see. X is equals to 2, x is equals to 2, previously we got 0 and we got again 2, then what I have done, 1 plus 0, which is equals to 1. Okay, now if we are standing at 2, what I have done, previously we got one element of 2. Okay, one element of 2 and plus 1, which is equals to 2. Okay, so this is how I am calculating the count of x and count of y, and simultaneously storing the difference of I also. Okay, this one, this array. Okay, so now our next step is to make the unordered map and store the frequency of difference. Okay, what I have said just now, 0 is coming 1 times, 1 is coming 4 times, 2 is coming 1 times, that I have stored in the map. Okay, done, this step is done. Now I have initialized the answer variable as mp of 0. What does it means? Means whatever number of 0 I am getting from the difference, or from the map, we'll be checking that what is the number of occurrence of 0, then we can directly put it in our answer, because the difference of x and y is 0. It means that the number of occurrence of x and number of occurrence of y is same. Okay, initialize the answer as mp of 0. Now we'll be iterating the map part, means map part, and we only want the second map it dot second. Okay, second value. So we take the frequency as it dot second, and we are calculating that frequency into frequency minus 1 by 2. I have taken it as long to just to like avoid the overflow of the int variable. So finally answer is equals to answer plus frequency, the handshake formula, and finally returning the answer. So let's submit this code. It's giving right. Okay, so let's submit it. Okay, so it has passed all the test cases. So this is how we are solving this problem, and we have solved this problem in big of n complexity. The time complexity of this problem is big of n, and the space complexity is also big of n, because we are using the unordered map. Okay, and previously the approach 1, we can solve this problem as big O of n square time complexity and big O of one space complexity. So I have explained you both the approaches. So this is how we solve this problem. So thank you for watching and having patience. So thank you.